In this session, we will see how to do bubble sort. So let's directly start with an example. So let's consider this data. These data are stored in an array. So these data are stored in an array named K, and array index starts from 0, 1, 2, 3, 4, 5. Length of this array K is 1, 2, 3, 4, 5, 6. 6. We'll denote length as n. So in this example, n is equal to 6, which is nothing but the size of array. So in bubble sort, consecutive elements are compared. Let's represent array index as I. So in this case, I ranges from 0 to 5. So I is equal to 0 to 5. So in bubble sort, as mentioned before, consecutive elements are compared, which means I will be compared with I plus 1. That is K of I. Element at ith position will be compared with element at I plus 1th position. We will see all the cases. If I is equal to 0, K of 0 and 0 plus 1 is 1. K of 1 will be compared. In this case, I will be 1. So K of 1 and K of 1 plus 1 is 2. 2 will be compared. Next case, I is equal to 2. So K of 2 and K of 3 will be compared. Similarly, if I is equal to 4, K of 4 and K of 5 will be compared. So we have indexed till 5. So this will be the last comparison. What sort of comparison are we going to do? So here, this is the given set of data, and these data we are going to sort it. So this sorting can be ascending order or descending order. By default, sorting means ascending order. So in this example, we are going to sort. We are going to do bubble sorting. Final output will be the ascending order of this data. So let's try it manually without any algorithm, without any sorting techniques. Let's try it manually. So ascending order means, in ascending order, smallest element comes first and largest element will come in the last position. Whereas in descending order, it is just the opposite. So now we are going to arrange these elements in ascending order. So let's say which is the smallest among this given set. Minus 46, right? So minus 46 comes first and followed by minus 2 is the second lowest. So minus 2, then 0, then 1, 3, 8. 0, 1, 3, 8. So this should be our final output, right? This should be our final output. So we can see that smallest element occupies the leftmost position and largest element occupies the rightmost position. And it is in the gradually increasing order. So when we are comparing I and I plus 1th element, okay, so how should be our final output? Ith element should be lesser than I plus 1th element, right? This is ith element. This is I plus 1th element. This is lesser than this. 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 And 3 is lesser than 8. So we want to check if K of I is lesser than K of I plus 1. Okay. So in each case we have to do this. K of 0 is lesser than K of 1, K of 1 is lesser than K of 2, and so on. So what if it is not lesser? If it is not lesser, we have to swap the elements. So we will see that. So we are going to check K of I is lesser than K of I plus 1. If it is lesser, it means that those two elements are in correct order. Then we don't have to perform any action. So no action. Whereas, what is the else case? Else, if K of I is greater than K of I plus 1, then we are going to swap the elements. What does swap means? Interchange the elements. For example, if we have 8 in ith position and in I plus 1 position we have 3. So we are going to check this 8 and 3. Okay. So is 8 less than 3? No. Is 8 greater than 3? Yes. So we are going to swap this. Means 3 comes first, 8 comes second. That is, now in ith position we have 3 and I plus 1 position we have 8. Consider this example. Now we will try to solve this using bubble sort. So first case, I is equal to 0. When I is equal to 0, we are going to compare. We are going to compare K of I with K of I plus 1. So now we have I as 0. We are going to compare K of 0 with K of 1. So what is the condition? If it is lesser, no action. If it is greater, swap. So we are going to check if it is lesser. So what is K of 0? K of 0 is 3. What is K of 1? It is minus 2. So 3 is greater than minus 2, right? So in this case, K of 0 is greater than K of 1. It is greater, so we need to swap. So we need to swap. Swap what? This 3 has to occupy this position and minus 2 will come to this position. So after swapping, our array will look like this. This 2 got swapped. All the remaining data will occupy the same position. Next case is I is equal to 1. So we will be comparing K of I, which is 1, with K of I plus 1, which is nothing but 2. So K of 1 is 3 and K of 2 is 1. 3 is greater than 2, which means K of 1 is greater than K of 2. So the same condition, we need to swap the two elements. Which all elements? Elements at ith position and element at second position. We are going to swap these two elements. This one will go here, this will come here. All the remaining elements will stay at the same point. Will stay at the same position. So minus 2 will remain there. 1 comes here, 3 comes. So minus 2, 1, 3, 8, minus 46, 0. Next case, I is equal to 2. So K of 2, I plus 1 is K of 3. So K of 2 is 3. Okay. K of 2 is 3. K of 3 is 8. So 3 is less than 8. Which means K of I is less than K of I plus 1. So we have this. K of I is less than K of I plus 1. So no action has to be performed. So no action. So 3 and 8 will stay at the same point. 3 will stay here, 8 will stay here. It stays at the same point. Now we have I is equal to 3. So K of 3 and the consecutive element is K of 4 will be compared. Which means 8 and minus 46. So 8 is greater. Which means K of I is greater. Sorry. Which means 8 is greater. That is K of I is greater. Which means we need to, this condition, right? We need to swap. So K of 3 and K of 4. K of 3 will go here. K of 4 will come here. So remaining all other elements occupies the same point. So minus 2, 1, 3, then minus 46, 8, 0. So now I is equal to, next is I is equal to 4. So k of 4 and k of 5, which is the last case in this iteration. So k of 4 and k of 5, both of this will be compared. That is 8 and 0. So 8 is greater than 0. So we need to swap. Why? Because k of I is greater than k of I plus 1. So we need to swap. Okay. So swap these two. Array will become minus 2, 1, 3, minus 46, 0, 8. So this is the first iteration. So now that we have completed the first iteration, or first pass. This is called first iteration or first pass. So let's see the output after first pass. So what you can see, so now we know what is the final output that is required. So this should be our final output. Smallest should come this side, followed by largest. In this output, if we compare this to output, we can see that 8 is at the correct position, right? Which means that after first iteration, this 8 has already occupied its final position. So in bubble sort, whatever be the data, not only in this case, not only in this example, whatever be the data, after first iteration, the largest among the data will occupy the last position, which is its final position. So when you consider the second pass, you don't have to look at this element. We'll ignore this. Second iteration, the size of the array can be written as n minus 1. Why? Because one element has already occupied its final position. Now we don't have to consider this. So for the second iteration, we need to consider only these 5 elements. So here we have the second point, that is in bubble sort, after first iteration, largest element will settle down at its correct position. This is the second point. Before going on to the second iteration, let's see one or two questions that can be asked in NET or GATE exam. So one possible question is, what will be the output after first iteration in a bubble sort? So in that case, you have to do until this step. So this is the final output after first iteration. Another possible question is, after first iteration, how will the array look like? So there can be multiple options. Like the largest element occupies the last position, the smallest element occupies the first position, or the largest element can occupy the first position, or the smallest element occupies the last position. So from this you have to understand. So the answer is largest element occupies the last position, and this is in case of ascending order. Okay, we are doing these steps in case of ascending order. What happens in descending order? That we'll see in another example. Okay, so this is the case of ascending order. So in ascending order, after bubble sort, largest element will settle down at the correct position. Now we'll see second iteration. So now we'll consider this array: -2, 1, 3, -46, 0, 8. We are not going to consider 8. We are going to do the same things again, same comparisons again. That is, first case is I is equal to 0. So this time we will do it a little faster. So I is equal to 0 means -2. So we are going to check -2 and 1. Which is greater? 1 is greater, right? Which means -2 is already in the correct position. So we don't have to perform any action. Next case, I is equal to 1. So we are going to compare I is equal to 1. I is 1. So 1th position we have 1 and I plus 1th position, that is 2. At the second position we have 3. We are going to compare 1 with 3. Okay, so 1 is already less. So again the left side is less. So no action to be performed. Next case, I is equal to 2. That is, we are going to compare 3 with minus 46. Okay, so minus 46 is lesser. So we need to swap. Why? Because minus 46 should come at the left side. Lesser element should come at the left side. So this minus 2 and 1 will remain in the same position. Then we are going to swap these two. So minus 46, 3. Then the remaining elements, which is 0 and 8. So next is I is equal to 3. So 3 and 0. We are going to compare 3 and 0. 3 is greater. So we need to swap these two. Swap these two. So minus 2, 1, minus 46, 0, 3, 8. In iteration 2, we can stop at I is equal to 3. Why? Because we are not considering this. We are not considering this element. Okay, our sample size is n minus 1. For second iteration, our sample size is n minus 1, which means we don't have this element. 8 is not present. Okay, so in this case it is done. But even if we are not reducing our sample size, if we are keeping it as n only, then we have this element also. In that case, we have to perform I is equal to 4 as well, which means 3 is compared with 8. It will be less. 3 will be less than 8 because 8 being the largest element has already occupied the last position. So if we compare 8 with any of these elements, 8 is going to be the largest among all these elements. So that is why we are not considering this. So this will be an unnecessary step that we will be carrying out because no action will be performed here. Okay, so by this we have completed second iteration or second pass. So what happens after second pass? After second pass, second largest element will settle down at its correct position. Which is the correct position? In ascending, when we are writing in ascending order, it will be n minus 1 position, provided array starts from 0. Okay, n minus 1 position. See, if we have this array, suppose this is the array. If the array index starts from 1, 4, 5, then n is equal to 5. Okay, so n minus 1 means 4th position. So after second iteration, second largest element will occupy this position. Okay, so n minus 1 position only if the array index starts from 1. If array index starts from 0, you have to see and write accordingly. Okay, see, let's see. If array index starts from 0, okay, we have this. Array index starts from 0, 1, 2, 3, 4. Okay, so our n is sample size, n is 5. So our sample size is n is equal to 5. Usually we write the sample size as n is equal to 5. Okay, so a of n means a of 5, right? So in this case, there is nothing called a of 5 because array index starts from 0 and it ends at 4. So the last element will be present at a of n minus 1. Okay, so the second last element will be a of n minus 2. So if array index starts from 0, then after second iteration, the second largest element will occupy n minus 2th position, n minus 2nd position. Okay, so this will not be n minus 1, this will be n minus 2. So if asked for gate question or net question, you have to understand what is the array index starting, if it is 1 or 0. I suppose this portion is clear to you. This is the end product after second iteration. So after second iteration, these two elements are fixed. So for the third iteration, we need to consider only these 4 elements. So let's go with third iteration. So we are going to write minus 2, 1, minus 46, 0. 3 and 8 are already sorted. So we are going to continue the same steps until this array is sorted. So first case is, so this time we will do it a little more faster without looking at the condition. By now the condition should be clear. It is simple. The left hand side should have the smallest element. So let's see, without writing the steps, let's see by looking into the chart if we can do. So we are going to compare -2 with 1. So -2, lesser one is -2, it is already in the lowest position. It is already in the left side. So next, 1 is compared with -46. So -46 is the smallest. So it should occupy the left side. So -1, -46, 1. We are swapping this to, all other remains same. Next, so we have compared till I is equal to 2. Now we are going to check 1 and 0. So in 1 and 0, 0 is the smallest one. So 0 should come here and 1 should come here. All remaining things should remain at the same position. And this was already sorted. We don't have to look at that side. So this is the output after third iteration. This is third iteration. So what happened here? Third largest element, which is 1, occupied its correct position. Now we have these 3 elements lying in the correct position, 1, 3 and 8. So we have to continue the process till we get the final output. So now we have fourth pass. So without -2, -46, 0, 1, 3, 8 are fixed. We are not going to look at this portion. We will see this 3. So this should be compared with this, which is the smallest, -46. -46, -2, 0. Okay. So compare this with this, which is lowest, -2. No need to perform anything. Write the remaining element, 1, 3, 8. So this is the final output. -46, -2, 0, 1, 3, 8 in ascending order. Okay. We will cross check it. So we will cross check it with the answer. -46, 2, 0, 1, 3, 8. So this is how bubble sorting is done. So now we will see how to sort the elements in descending order using bubble sort. So again we will consider the same question. -2, 1, 8, -46, 0. So now let's see the descending order sorting. So let's consider the same example 3, -2, 1, 8, 46, 0, -46, 0. We are going to do sorting in descending order. So in descending order, the largest element should come first, then it should decrease, and the smallest element will be coming at last. So how can we manually, so we will manually try to sort this. So which is the largest element? 8. Second largest is 3. Then 1. Then 0, -2, -46. So -46 is the smallest element. So this will be the final output. So how does our algorithm, so how can we write the algorithm? So this is the array K. So this is array K. So we are comparing K of I and K of I plus 1, right? So when you look at the final output, we can see that towards the left side we have elements that are greater, and towards the right side we have elements that are lesser. So left side should occupy the greatest element. So when we are comparing K of I with K of I plus 1, If k of I is greater, that is left side is greater, that is what we want. So we don't have to do any other action on it. So no action. Otherwise, if k of I is lesser than k of I plus 1, which means that the first element is lesser. Okay, so when we check this, suppose this is I and this is I plus 1. This is lesser. This is greater. So we have to swap this because we want the greatest element to occupy the left position. So swap. So this is how we do it in descending order. So this was the rules for ascending order or simply sorting, because ascending by default it is ascending order. So if it is ascending, these are the rules. If it is descending, these are the rules. Okay, ascending, descending, it is just the opposite. The symbol will be just the opposite. Okay, so let's try only the first iteration of descending order. Let's just do the first iteration, then you will get an idea on how to proceed with it. Okay, so 3 minus 2, 1, 8 minus 46, 0. So compare 3 with minus 2. 3 is greater, so no action. Then minus 2 with 1. Minus 2 is lesser, so minus 2 has to go to the other side. So 3, 1, minus 2, 8 minus 46, 0. Remaining all I have written it that way. Next, minus 2 and 8. 8 should come this side because 8 is greater. Now, minus 2 and minus 46. Minus 2 is greater, so this is correct. Minus 46 and 0. 0 is greater, so 0 should come this side. Minus 46 should come this side. Remaining all remain same. So this is the answer after first iteration in descending order. First position occupies the correct element, right? So the smallest element occupied the last position. So now we will ignore this and we will sort this. So what will be the output after second sorting? Can you predict? You can't predict the remaining things, but you can predict what will be coming in this position. What will it be? It will be minus 2. After second iteration, this will be minus 2, minus 46. Remaining, we have to solve it to know how the output will be. Okay, so what we can conclude? So in bubble sort, after first iteration, the last position occupies the correct element. Correct element means the final element which will not be altered in the remaining iterations. I hope this is clear to you. If you have any doubts, you can contact me in the email address that is given in the description box. Thank you.